Okay, so let's get started. Could you confirm if my screen is also visible?
Ma'am, visible, ma'am, in the last assignment, question number 12, it has two, what you say, answer correct.
Okay, that is possible, right? Because we discussed that the
No, but in that only one option we can mark, na?
no, that is multi-choice. You can use multiple
No,
options.
no, 12th one is,
Okay, 12th one.
there are two answers, which is, no, it is not
Mm,
12th. It is, I
which
believe.
question?
Can you scroll down, ma'am?
You mean this is the last? You mean scrolling up?
11th question, 11th question. 11th
Okay.
question, I have two answers correct.
Let me check. So this is find out which all matrices. Okay, we will do that, but I think since a lot of students or attendees they are attending today for the first time, let me just introduce them to these sessions and then we'll get started with solving the questions. Does that sound good, Anupam?
Yes, ma'am, yes.
Okay, thank you. Okay, so good evening, everyone. I'm Suman Raj, and we are taking these TA sessions as a part of PMRF. So, this TA session usually happens 6 p.m. to 8 p.m. every Saturday. So, please feel free to join this one or the other one as well. Um, and this is usually held on Teams. So, what we usually do is for every week, you get the lectures that are uploaded on NPTEL, probably around Monday or so. So, try to go through the lectures first and then try to attempt the questions that are there in the assignment. And then what we do in these sessions is that we try to revise the contents that has been uploaded already, and then we go through some of the assignment questions, some of the sample questions as well that will help you solve the assignment question. And then later we try to go through the assignment of the current week, and just discuss any kind of doubts or if you need some help to solve the question. Okay, and in the next week, so if let's say next week is going to be the deadline for week 1 as well as week 2, so after that, if at all you feel that you could not understand any questions answer or anything of that sort, because they will be releasing the answers only by then, right? So we can discuss as to why those answers are correct and why not, so that it can eventually help you understanding the course and eventually in the final exam as well. So this is what the pattern is. And if today is your first session, then one thing I just wanted to let you know about more about from the operational thing is we usually use this chat window for the questions, and also you can ask questions there or you can give any kind of suggestions as well. Okay, and if at all you need to ask any question, then please raise your hand and then we can just discuss that also. So you can unmute yourself and then we can discuss the same. Okay, and apart from that, so whatever I am discussing over here, the PDFs are being uploaded in the drive, and the call and the meeting that we have right now is being recorded as well. So the YouTube link of the video and the PDF of these materials that we discuss both will be uploaded in the log sheet. And most of you, if you have registered for the course, you would be getting the email to access the log sheets as well. Yeah, so this is majorly the format of our sessions. Does anybody have any doubt in this part? Okay, since there are no doubts, let's move ahead. And every week we try to, discuss the summary of the content in week whatever current week content is, and then we will be solving the questions. So this week content was real time sensing and communication for CPS, and the last time was motivational for CPS. Okay, so before I start this week 2 practice assignment, since Anupam had a question, we'll just go back there. And since we are discussing week 1, so this is a question from the last week's assignment in which he is having a doubt. So if any of you also have a doubt, please let me know so that we can discuss that now itself in the same time. Okay, so this question says find out which matrices below are orthogonal, symmetric, and skew symmetric. Okay, so symmetric means that you have A is equal to A transpose. You have skew symmetric here, and then you have your orthogonal also. So you are saying that there are two possible correct options. Okay, I cannot reveal the answers because the assignment due date is later, not right now. But let me see what can be done. Mm-hmm. A is equal to A transpose is called as the symmetric. Okay, that is fine. Um, I don't see two answers here, Anupam. It's only one of them. Specifically, in which of these options do you have doubts in? Like, what is that particular, like
Ma'am,
A1, A2, A3, or A4?
ma'am, I A2 is orthogonal also and symmetric also.
Okay. So, in that case,
And A4 is orthogonal. That is true. But A2 is both, ma'am, symmetric as well as orthogonal. Can you check this? This will resolve.
that will resolve, but you have to choose one of the options that is giving you all what you think, right? So, um,
You just you concentrate on A2 only. That's all. A2, rest all is okay. A2 is orthogonal as well as
that is
what you
correct.
say.
Yeah. Okay. Symmetric.
If you see, there are two answers in which this can happen.
Hmm. Okay. Just a second. But you have to check for all options, right?
I've already checked all options, but what I want to say, if A2 has two orthogonal as well as symmetry, then we can select two. Na? That means A and C both can be selected. That is my what you say
But you
doubt.
have to check for others also, like check for A1, check for A2, check for A3 and
So,
A4.
so if you see and if you see A and C, other A1 and A4 has no conflict. Only conflict is in what you
But you
say.
have to check for A3 also, right? A3 are
A3 also.
different in A and C options. And
Yes,
symmetric and
yes,
skew symmetric cannot be the same, right? It has to be
yes,
one.
yes, 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 yes.
So,
Okay.
so does this help you?
Yes, yes, yes.
Okay, great. Yeah. Okay. Any other question here in the week 1 assignment?
Can you scroll from first to last? Ma'am?
Okay, you want me to go up to down? Okay. Yeah.
So in this we have already cleared that Schuller stable is what you said ki that
Oh
absolute of
yeah, I said that I'll be checking it in the demo, but I when I actually went through this exactly, it's a very simple question that they are asking
yes,
for.
yes. So this we
Right.
got. But if you see the
Okay.
first question, this is
Mm-hmm.
also what you say, you cannot put answer here. And you confirm this.
What do you
Can
mean
you?
by you? We cannot put answer. Is it like UI issue you are seeing, like on the internet?
No, ma'am. See,
The
if
browser.
it has a negative value, so you cannot put
Okay.
negative here. The answer is, suppose if I say answer is -10, you cannot put minus in this.
Is it?
So
One second, let me check.
just check
Um,
and confirm.
sure, sure. I'll just do that. You can put. I think you can put. It is fine. It is taking a minus, I mean, a negative number from my end. So you can put a negative number.
From my tablet, I don't get minus sign. So my point is determinant of cofactor of this is the ma'am. This is matrix. It is given, na?
Yeah, yeah. This is a matrix actually. They shouldn't have put this like this. It
So,
should be like
so
this. Yeah.
yes, yes, yes. So
And
one
then
out
you
of
take the
four.
cofactor of this, and then you take the determinant of that.
So that can I say answer?
No, you should not. Because see, I mean, ideally we can discuss that, but keeping the like
So can
the
we take
spirit
another
of the.
example and then you can show so instead of this matrix, can you take another matrix then?
Sure. What do you need for that? Tell me. You want me to take another example and just.
Yes, ma'am. Same question
Okay.
uh, with different what you say matrix.
Okay, let's do that. Mm, let's see if you have 2, 3, 4, minus 1, minus 1, minus 1, 4, 5, minus 3. Okay.
Now let us do and then we will show you. So now answer is, if you say answer is um,
So can you calculate the cofactor of this
yes,
matrix
yes.
that I have written over here? Tell me.
Cofactor is -1, -1, 5, -3.
The, no, it won't be like this. It will be a 3 cross 3. Okay, okay, sorry. It is going to be 2 cross 2.
-5, -3.
Mm,
And then we
okay.
have to take determinant. 3 plus 5, 8.
3 minus
So
5, right?
yes, no, it is yes, 3 minus 5, which is -2.
Okay.
So this
Let
answer is
me
-2 is
just.
okay.
No, no. Just let me. Yeah, they should have specified which cofactor. There would be multiple, right? So, I'll tell you. This is one of the elements that you have calculated, okay? Um, so once you calculate that, so the minus 2 that we got, right, going to be one of the elements of your cofactor, not the entire thing. Okay? So how do you calculate the cofactor in your part? Can you tell me? Are you using MATLAB right now? Am I audible?
Yes, yes, yes.
Okay. So when you are calculating, when you told me this portion, right? This is cofactor of 1 comma 1. It's not the cofactor for the entire
So we have to calculate for
thing.
entire 9 elements.
Yes, you have to do that for all the 9 elements, and then you have
Yes,
to
yes.
take the determinant of that particular matrix. Does that help clear your doubt?
Yes, ma'am. Yes, yes. That I know. Okay.
Okay.
That is why this MATLAB we have to give this as a as input, and then this is the command what you said, and then MATLAB will give the within one what is second. So for
Yeah,
that,
so actually for the cofactor also I gave you the command in the last meeting, right? What was the command? Um, yeah, there was this thing, no? So you can do um this was the formula, so you could just calculate the cofactor using that also. So
what
basically it should be determinant of A, which is this, into inverse of A, which is this, the whole transpose. Okay. So over here, when you enter your A value, for your cofactor, you should be getting determinant of A into inverse of A, the whole transpose. Is that good?
yes, ma'am.
Okay. Any other question?
No, one is okay, two is okay, then three is also okay, four is also okay, fifth is sixth is also, seventh is okay, eighth okay, ninth we have clarified,
Mm-hmm.
10th.
Okay. Tell me. So you want me to discuss the 10th question? Okay. This one we clarified. Okay. So this says this particular equation is a second order ODE. So y1 dot is equal to y2 and y2 dot is equal to all this. Fine. So the following code evaluates this equation for mu is equal to 1 and initial values of this for 0 to 20 units of time. Okay.
Function defined is dy by dt is equal to then v
This
dp.
is just Vanderpool. That's what it's just the name of that function.
Ma'am, see, once we say y1 dot means dy by dt, na ma'am? Dy by dt. So whenever we say differentiation, it is dy by dt, na? So now they are not, they are saying dy into dt.
Hmm. So y1 and y2 are two of your parameters. So this is y2 is 1 and then you have y2 into this portion you will have to write over here because mu is equal to 1, so you will write 1 minus y1 square, right? That is your equation. And
And in the answer, what is at the rate vdp? At the rate vdp,
so vdp is actually the name of your
no,
function.
no. See, at the rate, I have never come across this term in this what you say
Okay, let
anywhere.
me just. So have you checked out the declaration of this OD45? How it happens in MATLAB? There is a specific format for that, and this is a second order ODE, right? So you would need something like this. Just a second, I'll share that with you. Yeah. So you will see that at the rate over here. Can you check the link that I have shared? So the name of the function that we define, that goes over there. Okay. So this is VDP1 that they have defined over here. So they are trying to call that particular VDP1 over here. So the first one I would just tell you, just to help you understand how I mean these function parameters work. So the first one is going to be your um, the name that you assign to that particular function, or basically what you call, what function you call. Okay, so that is going to be VDP1. Did you check the example that I've shared?
Yes, ma'am. I've just seen that MATLAB, what you displayed.
So if you see that there is a function dy is equal to fun(xy), correct? I'll just write it over here just for your reference. So by this word function, you're actually saying that you are trying to define a function. Now when I say dy dt is equal to, over there they say fun of x comma y, correct? And later what do? They take out this x comma y because that is going to be the output from your ODE, right? 45. And what do they do first? They have at the rate fun. So what are you going to have at the rate VDP? Because that's how they want to solve that particular differential equation. Is that fine? And over here, the parts that they have actually put, right? Um, 0, 9 and 0 minus 28. So that's actually what are the values for these two. So for x, sorry, it is 0 and 9. Okay, and y varies from what? For them it is 0 and minus 28. Okay, so for you, you have two functions, right? Y1, I mean two variables, yn and y2, right? So the initial values of these two are 2 and 0, and your time is 0 to 20, correct? So accordingly you can fill.
Yes, ma'am. Cleared. Okay.
Got
Thank
it?
you.
Okay, great. All right, should I move next?
Yes, ma'am.
This we discussed. This also was discussed extensively in the last session, and the last one is, I think, easy enough.
Second assignment, can we, ma'am, scroll through? Oh, this is
Sure.
second one also.
No, no, this is week one only. But before going through the week two assignment, I wanted to like solve some sample questions, and then we can go to um, the week two assignment that you have right now, so that while solving the sample questions itself, you will um, get help for some of the questions that you have right now. Okay, so I think we can start with week two practice assignment. Before that, let me just take a head count. So, how many of you have gone through week two lecture recordings on NPTEL? Nice. Who else? Good. Okay, great. So, two of you have gone through. That's good. So, s- okay, Harshal, you just finished week one. Okay, so I think you will have to catch up. Um, so for now, what I'll do is I'll go through the questions itself because some of you have already gone through the lecture. So um, it's good that we start with the practice assignment itself. And if at all any of you do not understand, or if you are not able to follow, then please let me know. I'll just stop and refer to the lecture slides, and then you can um, I mean, let me know if you understand that also or not. Okay. But yeah, it's good that most of you are following the lectures and then coming to the session. That's nice. Okay, Anupam, you can lower your hand.
How to do that?
Just click on that again. It will go down. Yeah. Good. Okay, so here is the first question. Okay, nice. So Shivang also agrees with us. So the first question is choose the correct matching from the following options. I hope the font size is fine. So there is some sensor name and we have some technology used. Okay, so we have, so I think this was the very first slide also in the lecture recording. There was accelerometer, we had gyroscope, and we had wheel speed sensor. Okay, and then we have some effects like Coriolis, Hall, or piezoelectric effect. Okay, so can you help me match these, like which one is which over here, and how do they
We,
actually work? And if they work, I would want to know what do you understand by these effects. So that would be a better revision of our session. Yeah, go on.
wheel speed sensor is Hall effect sensor. Wheel effect, wheel speed sensor is Hall effect sensor. Then gyroscope is Coriolis effect, and
Okay,
then astrometer is piezoelectric effect.
okay, that is good. Can you explain any of these effects as to what they mean? So B is the
Wheel
correct answer. Yeah.
wheel effect, wheel speed sensor is what we see. We place some small magnet,
Mm-hmm. Nice.
and then whenever there is electricity is passed through in a metal or in a substance, the
Mm-hmm.
charge will accumulate with effect of the that what you say, that magnet which is coming. So
Mm-hmm.
the voltage across that metal will detect the Hall effect, the presence of magnet.
Okay, so basically over here you have some kind of a metal, right? And when you are bringing
The magnet,
there is some kind of an effect, and because of that
yes,
we have this voltage that is created across this
cross
metal
opposite,
piece, right?
opposite. Yes, yes,
Right. Okay, nice. And Shiva has for piezoelectric effect, which is the process of creating electricity due to mechanical stress. That is correct. Anybody for Coriolis effect? These two are covered.
Coriolis force will be the perpendicular to the two, what you say, forces, just like what we have in centrifugal or centripetal force.
Mm-hmm. So what are those two forces?
So one is that what you say, angular velocity. Second is the linear velocity. So FC is V cross omega,
So it
and the
should.
mass.
Mm, V. So if F is here, so this should be your V and this should be your omega. 2
The
mV.
Coriolis effect is the minus sign will also come, and the mass on which this is this, yes, minus 2 MeV.
That comes because of the understanding, right? Because of the cross thing.
Yes, yes,
So
yes.
correct. Okay. So this is good. Okay. So I think we can move on to the next question. If anyone else is having doubt, please raise your hand or please just type in the chat window because I'm continuously monitoring the chat window also. Okay, so let's move on to the next question. This question is exactly using the formula that Shiva has put in the chat window. We say that the sensing mass block of this gyroscope, which is actually using your Coriolis force. Okay, so we have a mass of 0.0001 kg, Then you have your V as 7.2 kilometer per hour. And this is along x-axis. Okay. Along your z-axis, what do you have? You have your omega, which is 0.08 radian per second. Okay. And then what do we don't have anything else? Okay. So we have to take out FC, which is along y-axis. So as you said, this is correct. So it should be 2m omega cross V. Okay. But because your W is across z-axis and your V is across x-axis, so the cross product is actually going towards minus y-axis. I think that is the case. Let me just confirm it. So this is your x, this is your y, and this is your z, let's say. Then your x-axis is having V, and your W is in the z-axis. So z cross W is actually going the positive y itself. Okay, so I think the minus is always there whenever we have omega cross V. Okay. So this is your FC over here, and if you try and calculate, so we get minus 2 into what is your mass, 0.0001 kg. Um,
We have to convert into meter per
and
second.
then you have, yeah, this one we have to convert. Yes. So how much will this be in meter per second? Can you calculate quickly?
We have to multiply by 1000 by 3600 bracket.
Correct.
7.2.
How much is this? 2, right?
2.
Correct. So this is going to be 0.00. I mean, I'll just write it in this format. Okay, so this is going to be the answer for this. So just like this, I think you have a question over here with different values. Okay, so I think this question you all should be able to do. Okay, so it uses the same um, formula that is given over here, but just take care of this positive and negative signs. Okay, just see if the cross product is working fine. So let's just see if it's the same or not. So here V is across x-axis. Okay, and W is across z-axis. So it is going to be the same. You can have the same formula. Just substitute the values which are over here in this question and you should be able to get the answer. Okay, moving on to the next question. This is from this Hall effect. Let's see. So the question says that you have a silver sheet with cross section of 1 centimeter cross 0.5 centimeter. So your area is actually 0.5 centimeter square. Your current is 100 amperes. So a current is being passed through this metal, which is of 100 ampere, and this is going from left to right. Okay, so your current is going in this direction. Now this is placed in a uniform magnetic field of this magnitude 1.60. Now consider there are these many number of electrons, and this is an approximate number. 6 into 10 to the power 28 electrons per meter cube. This is what is the number for silver because this is a silver sheet. Okay, so we have to calculate the Hall potential between the edges of the sheet. So since our magnetic effect is in this direction, we are going to have the voltage that was like that, right? So this one gets created, a new voltage gets created, and that is your Hall potential. So one electron carries 1.6 into 10 to the power minus 19 coulomb of charge. Okay. So the formula that we use is Hall voltage is actually equal to I into B into L divided by N into E into A. So it's actually that formula that we study. NEVA is equal to IB into L. Okay, so this is what we have in our class 11th some chapter as well. So the same is being used over here. So let's see, it's 100 into 1.6 into what is our length? It's 1 centimeter. Okay, divided by 6 into 10 to the power 28, and your E is 1.6 into minus 19 into 0.5 10 to the power minus 4, right? So how much is this gonna be? 3.33 into 10 to the power minus 6. So this is going to be our answer for this particular question. So this is how, if in future, I think in this assignment you don't have any such question, but if you have in your final exam also, you know how to solve these kind of questions. All right, any doubts in this question?
No, ma'am.
Okay, let's move on to the next question then. I think you have one question of this type in the current week also. So you have an analog value of 3.5, which you want to convert to equivalent digital output. So you are trying to do this conversion, analog to digital conversion. You have an 8-bit SAR ADC. Your reference voltage is plus 5 volt. Okay. So what is the output of the ADC at the end of fifth clock cycle? Okay, so your Vref is how much? 3.5 volt. All right. So since you have 8 bits, what is your resolution? Your resolution is going to be V divided by your actually Vref is 5. So the notations are a little different here. Let's say this is V input. Okay. So this is going to be Vref by 2 to the power n minus 1, where n is your number of bits. So what do we get? We have 5 divided by 2 to the power 8 minus 1. What is 2 to the power 8?
256.
Nice. We have 256 minus 1, which is 25 by 255. Okay. So this is approximately equal to 19.61 millivolt. All right. So now let's see. This is asking that what is the output of the ADC at the end of fifth clock cycle. So make sure, because this is different in the current set. So now let's say we start with the first clock cycle. So what was being taught in the theory, that every time you load a register in the first clock cycle, right? Let's say, so you initially load, register is loaded with 1000000. All right. So your output voltage is going to be 19.61 into 2 to the power 7. 2 to the power 7, why? Because this is going to be into 2 to the power 0 into 1 and so on into 2 to the power 7. Okay, so this is going to be 2.5 volt. And what is your V input? This is 3.5. So since your input voltage is greater than this that you have calculated, okay, so this is less. So what do? We retain the value in the register. Now, when you go to the second clock cycle, what is in your register? You load, you retain your 1, okay, and then you load the next one with 1 again. Then you have 0000000. So at one time you will change only 1 bit, and to retain or to change is the decision that you get after you calculate this output voltage. So now your output voltage is going to be 19.61 into 2 to the power 7 plus 2 to the power 6 millivolt, and this is going to give you 3.77 volt, which is definitely greater than 3.5, right? So you clear the bit that has been loaded. Clear the loaded bit, which means that after that, when you are starting your third clock cycle, your register is going to be 1000, sorry, 10, and then the next one is going to come, right? So 1010000000. Now your output voltage is going to be how much? It is 19.61 into 2 to the power 7 plus 2 to the power 5 millivolt, and that is going to give you 3.14. Again, this is less than 3.5. So what are you going to do? You are going to retain it, right? So now your fourth cycle is there. So in the register, what will you have? You will have 1, 0. You have to retain the third bit. So retain it, and in the fourth bit, you put 1 because this is your fourth cycle now, 0, 0, 0, 0, right? So now what is our output voltage? It's going to be 19.61, 2 power 7, 2 power 5, and 2 power 4. That is 3.45, and that is less than 3.5 again. So what do? We retain it, and then in the fifth cycle, in the register, we load the next one. So this fourth bit is going to be retained, and you have, sorry, it's going to be 1000. So your output voltage is going to be how much? 19.61 into 2 to the power 7, 2 to the power 5, all of this, which is 3.61, and which is greater than your 3.5 volt, right? So if it is greater, what do? We clear the bit. Okay, so after the fifth cycle, your values in the register is going to be 1011, but since you clear the fifth bit, it is going to be 0000. Is this correct? Let me know if this explanation is fine.
Yes.
Okay, great. So similarly, there is a question over here. Hmm, where is it? Yeah. So you have this question. You have a reference voltage of 1 volt. You will have your V input as 0.67, and you are always going to compare that in this. No, that you will do. So after the fifth cycle, if you continue, in the register, it is going to load 10110100. But after that, the value is still this, right? This is being loaded. So actually, after every retain and after every clear, I did not write what is the output of the ADC. I just said that that is there. So the next time when you load into the register, definitely you have to add the last bit. Yeah. So this is going to be your correct answer. 1011. I think the last correct. Huh. So option D. Yeah. So again over here, what you do is you have 0.67, and here you have to do it only for 3 clock cycles. And one more important thing is you have n is equal to 5. Okay. So when you are actually going to calculate this part, sorry, the resolution, what should you do? You have your Vref divided by 2 to the power n minus 1. So over here you will take 1 by 2 to the power 5 minus 1. Okay, so make sure these changes are properly done. Okay, so I think this question also you should be able to do. Should I move to the next question?
Yes.
Okay. All right. So in this question, it says if in a 4-bit weighted register DAC. So now we are talking about digital to analog converter, which is a 4-bit. So your n is equal to 4 over here. The register value corresponding to MSB. Does anybody know what MSB means?
Most significant
Most
bit.
significant bit.
Correct, correct. Yeah. So it says that MSB is your most significant bit, and the register value that is corresponding to your MSB is 5 kilo ohm. Then what would be the register value for? It should not be register value, it should be resistor value, right?
Yes, resistance, resistance.
Yeah. Okay. So what does this weighted register DAC says? Resistor. Yeah, that is correct actually. So weighted resistor DAC says that your MSB is always equal to R, okay, and your LSB is equal to 2 to the power n minus 1 into R. Okay, that's how you keep increasing the resistance values. All right, so if your n is equal to 4, what is this LSB? It is going to be 8 into R, right? So if your R is actually 5, your 8R is actually going to be 40 kilo ohm. This was pretty straightforward, right? So I think over here also in this assignment, question number this question number 9. Okay, so this is opposite. You are given LSB, which is 2 to the power n minus 1 into R, and you have to calculate MSB. So basically you have to find out R because this is equal to 32 kilo ohm. All right, so I think you should be able to get it. And you also know the value of R, N, which is 4. All right. Okay, let's go to the next question. Hmm, is this the same? I think this is same. So maybe I won't solve it, but I'll give you the approach how to solve this question. Okay, let's see. So again over here, so the diagram I haven't put, but it's actually referring the same. So let me just see if I can take a screenshot and put it there. Okay, so over here, you have your V reference as minus 20 volt. And what is this question about? This question is about a digital to analog converter, and your N is equal to 4. So this is the same, right? So you have your MSB where you have this R, and for your LSB, you will have 2 to the power N minus 1 into R. Okay, and that's why over here they have put R into 8, right? So this is how things work. And right, so over here, if you have R1 is equal to 8 kilo ohm, and you have your MSB as 4 kilo ohm, okay. So what is the output voltage corresponding to the input digital signal 1100? So it says 1100. So Yeah, actually, I'll just tell you the formula and I think you should be able to calculate it. So the output voltage over here, that is Y, okay, this is given as minus Vref into R1 by R into, you have to take this all summation. So since this is 1100, you have to take 1 into 2 to the power. Hmm, this is a little weird. You have I0, X0, 1, 2, 3. So it is actually 1100. Hmm. So it's taking in the opposite way. Let's see. So you actually calculate in terms of millivolt. You have 0 into 2 to the power minus 3 plus 0 into 2 to the power minus 2 plus 1 into 2 to the power minus 1 plus 1 into 2 to the power 0 millivolt. This is the direct formula. But if you are actually looking for something very generic, that is given as minus Vref into R1 by R into summation I is equal to 0 to n minus 1 x of I into 2 to the power I minus, this should be n minus 1. Okay, n is where n is your number of bits that you have. Okay, so I think you should be able to calculate and then you can um, get the answer to this. Any questions here? I think the formula is explained in the lectures. Probably over there also it is not derived like mathematically, but this entire like approach as to how this converter works, that is given, and also how do you come up with these resistors and how does this op amp actually works, those things are there. Okay, which is R1 and which is R, this is R1, this is your R. Op amp is always R1, correct, correct, yes. All right.
Ma'am, if we say it's like x3 is 1 and x2 is 1, so rest is we can okay delete it. So now if we apply op amp ka normal what you say formula,
Mm-hmm.
so V reference is 20
Hmm.
minus 20 millivolt. So minus 20 is common, so we can say 8 by 4 plus 8 by 16. Okay. So these are the two factor which is to be multiplied by what you say minus 20 millivolt.
Mm, correct, correct. Yes, correct. You are right.
So rest all we can okay because the bits are zero. So now if we say 20, first factor will come 8 by 4 is half. So it will come 10. Okay. Now
Mhm.
half plus 8 by 16. 8 by, sorry, 8.
Are you
It is
trying to
1.
solve the question right now?
Yes, yes. So it is 1.5. So 1.5 into 20, 1.5 into 20 millivolt. So that is the answer.
Mm, no, 8 by 4 is going to be 2, right? Anand pointed out. So you will have minus 20. This is 20, right? This is going to be minus 20. And then you have what? 8 by 4, which is going to be 2. And then you have 1 by 2 plus 1. Right? So this is going to be 3 by 2. So minus 20 into 2 into 3 by 2. You can just calculate. Right? I think if you solve it, it will happen. Don't worry. And this formula is actually taken like this. I mean, you are actually trying to see that this switch is being closed and this is being closed, right? And then you calculate the total current that you are getting over here. How you are getting this V is equal to this IR, and then you have this particular voltage that you are getting over here, and then yeah, so this basically entire derivation and how do you get that formula is being explained in the lectures, so that is there. Should I move to the next question now?
Yes, ma'am. Yes, yes.
Okay. All right. So this question says, let me just check if this question is there or not. Okay. So here this question says choose the correct option, and basic CAN protocol supports data. So can someone tell me what is the full form of CAN?
Control area network, and A is the answer, ma'am. All.
A is not the answer. Control area network. Yeah. So what happens in your CAN packets? You have these CRC fields, right? That make sure that your data integrity is maintained. But if you are saying about A option, it means confidentiality. But in the case of CAN, the basic CAN, what happens is if any node is broadcast, I mean sending a message, it is being transmitted to every other nodes, right? And it is being done in broadcast mode. So you don't have a confidentiality over there. What about authentication? So do we have any kind of encryption
No, no, it is
in the
not.
case of CAN?
No
It
encryption.
is not, right? So in
Only
yeah,
only
so
CRC is
since
there.
encryption is not there, correct. So there will be no authentication as well. So it is only D. This is your correct option. Okay, so let's go to the next one. This was a theoretical question. Okay, these are the only sample questions that we could discuss. But if we move here, any questions that you want me to specifically discuss over here? If not, I'll just go through each of them and see if something I can put in, some hints or something of that sort. All right. So this question says that, sorry, in a MEMS gyroscope, the Coriolis force is proportional to what? Right? So in this question itself, when we were calculating our force, what was the formula we used? We used this formula. Correct. So based on this, I think you can answer this question as to if it is going to be proportional to what. Right. Second question is discussed. Third is also discussed. This is the fourth question. Okay. So this question says that due to erroneous implementation, there are two ECUs A and B that are sending messages, message A and message B. So this is more about the CAN um, error mitigation part. Okay. All right. So we have these two ECUs A and B that are sending messages, message A and message B with the same ID. And over here in the error mitigation, sometime there was this thing that if you have a lot of messages, sometimes you need to decide your priority. And if you have a lesser ID, that gets a higher priority. Okay. So something like that. So since over here you have the same ID, so A and B both have the same priority. All right. Now consider that the transmission error count of ECU A at this moment is 128. So TEC of A, I'm just writing in this turn, 128, and of B it is 112. So since for both of them the error, I mean the ID is the same, so they are getting the same priority. Okay. But since the payload of this one is higher compared to A, and where is that? But let's complete the question. Now, at certain time, both these attempt to send messages to the CAN bus with payload values of 10 and 6. So the payload of A is equal to 10 and the payload of B is equal to 6. Okay, so the payload of A is greater than. So as per CAN arbitration property, both get access to the CAN bus. What would be the next TEC values of ECU A and B? So since the IDs are the same priority, but the payload of A is greater, so the priority of A is going to be greater than the priority of B. So A will be the first one to send a message. All right. So once A sends an error flag, so A will be sending an error flag to the CAN bus. All right. And since that is going to be in what? It is going to be in passive mode. And why? Because it is greater than 120. All right. So since this is going to be in passive mode, all of the flags will be containing all the recessive bits. Okay. So in that case, let me just go back to the lectures because there you have the numbers. Arbitration section, right? Yeah. So this is the part where you want the highest priority node to win.
Ma'am,
That is the first part.
ma'am, excuse me. Ma'am,
Yes.
hello.
Yeah, yeah,
Ma'am,
continue.
where it is written that if you have a payload more, then the priority is more, because it is not written anywhere. It is always written the ID. But now you said
Yeah.
keep payload is 10, so that is the priority.
There is a collision detection. Okay. Priority is definitely by this identifier that is there. So maybe I should not write this priority. I should just write that since
Yes,
this
yes.
one is the payload of this one is high, this one is detecting the error first. A detects error before B. All right. So in that case, then A sends the error flag. All right. So
Yes, yes.
priority is going to be the same for both of them because that doesn't change. It's more about who is sending the message first. Okay.
Whenever their error is there, now suppose error A is there, so
Mm-hmm.
the T of A will be increased by 8.
Yes. Yeah. So I think if you go through this slide itself, that is gonna help you because um, they are a bit easy. So I should not just reveal the answer that way.
Now
Yeah.
since A is having some error, so that means ECU B is right. EC is
Correct.
is
Correct. Yeah. So then B is not going to detect any error for you. So A will s- have one error flag that will release it. And after that, so B is not going to sense any error. Okay, so what is it going to say? It is just going to transmit your message. So in that case, if you are able to successfully transmit the message, what do you do to TEC? Like you have to update your TEC. So what should you do? Okay, so think about that. That should be fine. Should I move to the next one?
in fact
Question. Yeah.
message of B should not be there, ma'am. It should be REC. TC is only whenever there is transmission error. Now since
Yeah.
B is okay giving a successful message. So
Correct. So there should be something done to your transmission error count, right? Because you were able to successfully send one message.
yes, yes. So it will reduce one.
All right, let's move to the next question. So the next question is consider a CAN bus with this baud rate, and there are three ECUs A, B, and C, which are attempting to send their respective messages. And the message A, B, and C with different IDs and different payloads. All right. So since they are trying to send the messages at the same time, which is t is equal to 4 millisecond, the question says what is the lower bound of transmission start time of message A, which means that at what time have the other two messages been sent. Okay, so let's put them in priority order. It is going to be message B, then A, and then C, right? Because ID for this is 2, this is 3, and then this is 5. Okay, and what is the payload size? The payload size for B is 2 bytes, and then for this one is 4 bytes, and this one is what, 6 bytes. So the question says that what is the lower bound of transmission start time? So you are asking the transmission start time for this, which is basically the transmission end time for this. Okay, so if you try and calculate that, you should be able to get the answer for that one. All right. I think this is also over here that how you transmit, and there is a so in the lecture itself, the professor has explained using an example, but over there he has used in terms of bandwidth I mean the bandwidth consumption. But you can just use this formula. You should be able to get that. Okay. So this formula, and then yeah, basically I think that itself, because over here you know this baud rate, so you should be able to complete calculate the time by when message B finishes the um, transmission of message B. Okay, and then after that you should be able to get as to when you are going to start this. And this, make sure that this also you take into account, because this is your periodicity, I guess. Let me just check. Yeah, right. Now moving to the next question. This is exactly the same question that has been solved in the lectures. So I think you should be able to solve it. Okay. I'll just try to just help you a little bit. So you have this rate, and I'll extend this table. Okay. So you can have over here as
1.1
message
factor.
size.
Hello.
Sorry.
Ma'am, this 1.1 factor, what we multiply is safety factor.
No, no, no. It's not a safety factor. It is considering traffic into, I mean, keeping traffic into consideration.
This 1.1 multiplied by total periodic bits. So this
Yes.
1.1 safety factor, what I want to say.
Uh, I don't know, like safety factor, it matters in which context you are using, right?
I think in vehicular system, we take 1.1 as a safety factor.
Right, right, yeah. So it's a little different from that context. That's why I was not trying to use the word safety factor, but I don't know what should we put over here. So it's more like to incorporate some kind of variability. So you just add that 1.1 over there.
In aviation, we take 1.5 as a safety factor.
Yeah, that's what I'm saying. So safe, this is not a safety factor. It's more about these are the message bits that are being consumed in per period, like in one cycle, right? So when you are trying to take out the total bits consumed, you just multiply it by this, and you consider this part that it is the worst case traffic. If anybody else has some other explanation, they could go ahead. But that's why even in this question they ask you should consider the worst case traffic. Maybe there should be some physical meaning to this, but yeah, I'll just check this as to why exactly 1.1 is being multiplied over here. Is that okay, Anupam?
Yes, yes, yes. I mean,
All
the
right.
previous what we are discussing 4 millisecond. So in that
Mm-hmm.
4 millisecond, but in this question, the periods are different.
Yeah.
But in this question for all that period is the same. All this rate is same. Like they said same time 4 millisecond. Now in this question, we have message A is 10 millisecond, message B is 20 millisecond, message C is 100
100
millisecond.
millisecond. Right.
We have all the three messages with same 4 millisecond. What you want to say? This
Yes,
this is
yes. Right. So the next time any it's so every time you send a message only after those 4 milliseconds.
The same table we will calculate for the previous one question.
Yeah, you can calculate it that way, but I don't think it will be that difficult because you have different priorities. I mean, the priorities are given for you. In this question, it's not given. It's a little different. Over here, it's talking about the time. Over here, it's talking about the capacity. But if you want, you can definitely create a similar table because it's going to be the same kind of calculations that you do over there also. So as I said, right, this message size will be the same.
I'm not able to understand the previous question because say suppose 4
Mhm.
millisecond priority of message B is more as per
4
ID.
millisecond is not your priority.
No, 4 millisecond is
Okay.
the
Hmm.
time. So what I want to say, the first B will happen because of the ID less. So 4
Correct.
millisecond it will take. Second will only start after 4 millisecond. Na?
Yes, correct. It will start after 4 milliseconds of finishing of this, right? Because you need to send the message for this also. So that's why. So you just have to add 4 millisecond to whatever your end time of this is there. That's why it is asking the lower bound of transmission start time. That before that it is not going to start.
Payload okay. So but ठीक है, okay, I will try this.
Yeah, try that. Payload is actually going to come over here. So I'm writing this column, right? Message size of the bit. So that is your actual payload. Okay. So basically this is your payload.
Understood, ma'am. We will try this.
Just try that. Yeah, and over here you have to create another column that message bits consumed. Okay, and for message size, how do you calculate it? You calculate payload into, so this is in bytes, you have to convert it into bits. Okay, so you multiply it by 8 plus the 47 that you do over here. So we add 47 bits because of all these extra stuff that we add over there. Okay, so for each of them you calculate that. All right, and message bits consumed is actually how much? It's your bits that you get from here into this rate that you have. Okay, so you calculate that, you have a total sum over here that is going to be the message bits consumed for all the messages. Okay, so that is basically total bits, periodic bits consumed. Okay, and then you try and take like 1 second interval and see that how much over here it is taking, and then you multiply it by one, so don't forget that part. Okay, so multiply that by one, whatever you get you divide it by the rate that is over here, and then you just multiply it by 100, you'll get the answer. And this same question has been done in the lecture also, so you can follow that as well. Okay, let's see, is this question clear by the way?
Yes, ma'am. Yes.
Okay, let's move on then. Next question, this we have already discussed, so you should be able to do it. Okay, how does CAN bus eliminate traffic congestion in communication networks? This is a very theoretical question, so I would again suggest go back to the slides or go back to the lecture, and there would be an answer to this question. Again, question 9 we have discussed how you can solve it. And the last question says in a CAN network, a node starts in the error active state with a transmit error count TEC value of 0 and receive error count value of 0. Okay. During operation, the following events occur in sequence. Okay, so you have to do those things like calculate all those stuff. So let's say this is some node A or B, right? So you have to do these things in sequence. You encounter 5 transmission errors and you increase this by 8. You encounter this, you increment the REC by 2. You successfully transmit this one, so you decrement the TEC by 1 for each successfully transmitted messages. All right, so you actually minus 6 over here. And then you successfully receive 4 messages and each of them are decrementing your REC by 2. So again, minus 8. Again, over here it was 2 into 3 plus 6 actually. And then you encounter 2 additional transmission error and each of them are incrementing this by 8. Okay, so you just do that. So you have to determine the final state of the node after these 5 events. And this is actually based on this cycle that was explained. Okay, so you have to check error active, error passive, or bus off. Okay, so depending on what is your value of TEC and REC, you do this. Let me just take the screenshot and put it over there so that you know what to refer. Mm,
If TEC and REC is less than
uh-huh.
127, if TEC and REC is less than 127 as per this diagram, so then it
Right.
is error passive.
Yes, correct. So you have to start off somewhere. Okay, so start off in this. It said, right, you are currently in this state. It starts in this state. So initially you are here. Okay, you are in error active state. And then you calculate what you are getting. Okay, so initially you have to assume that you are in some state, and based on whatever is your current state, maybe maybe
Supposed to
in this sequence, at some point you might move to the error passive state. At some point you might move somewhere else like burst off and all. But you have to determine the final state after all the 5 changes. Okay.
So, ma'am, to start with, shall I take TEC and REC greater than 127?
No, to start off, you have to take TEC of 0 and REC of 0, and you are in error active state.
So
So
error
you
active,
move to this on this condition, right? So
no, no,
if you are in this state and then you calculated that either this or this increased by 127, so then you are in error passive state after maybe whatever 1, 2, 3, or fourth step.
error active state. What is the TEC and REC? First we have to take from there, na?
It's
Error
given in
active
the question. It is 0.
both. Error active state both are zero.
Yes. Okay, so I think we have reached the end of this question. So I think all the questions that we have discussed, you should be able to solve the assignment questions. And I think this week you have the submission deadline for both the assignments. So do well and try to score good marks over there. Um, yeah, and I think officially we can close the session. So anybody who has more doubts, please feel free to stay back and ask the questions. If not, please, I think you can leave the session. Thank you so much for attending. And we can meet next week at 6 p.m. again.
Thank you, ma'am. Thank you.
As IT engineer, how does this course help you in future or during placements? So I think at one point, if you are just working on the software part, but recently, I think the more and more we will go deep into the lectures. At some point you will talk about edge computing, fog computing, cloud computing, and how those kind of things are actually helping this cyber physical system grow. So that's where the main intersection of computer science will come into play. And I think that's going to help you there, because if you know how do these components, like these physical systems, interact with each other, leveraging the cloud systems or leveraging these edge devices, that's actually going to be helpful. And nowadays with these, compute devices becoming more and more powerful, everything is becoming on the everything is coming on the edge, or you or they are or edge computing is using cloud computing, like hybrid compute, or all those things. So that's definitely going to help over there. Is this the basis for IoT? I would say in one aspect, yes, because IoT itself is a very broad term, but in the sense of cyber physical systems, yes, you can say that. And this week was more about communication, so we were talking about this CAN network and all of that, about the bits and all of that, right, that we were discussing over here. And we also discussed this sensor type. But once in the next lectures we discuss about the software and how do you analyze data, or how do you use different kinds of compute. I think then you will get those different computing systems. Okay. Hmm. Yeah, I think the mathematics component will definitely be there, because if you look at the syllabus, the first week was more of motivational, but then we started with this communication part. And I think in next you have the task scheduling. So mathematics will definitely be there, and later on the control aspects will also come up. So I think in the lectures, whatever is being taught, if you follow that, that should be okay. Majorly it will be covering some parts of um, software, like real time processing and all of that, some parts of control, some of these communication based, but more in the context of cyber physical systems. And I think one is like, recently you're having AI, so how can you use neural networks and all for the control systems. So yeah, it's covering a lot of breadth, I understand, but it is that way. Lecture should suffice, and I would say just solve the questions diligently. That should definitely help you. And if you are not able to solve something in some assignment, so don't let that just be there. You still prepare for it, because you never know if those kind of questions will come in your I mean the final exam. Okay, so I would say that be thorough with the lectures, be thorough with the assignment questions and you should be good to go. If there is something that has to be explored extra, then I'll let you know, and even the lectures, like the professor will let you know in the lectures. But I don't think you should, I mean, it's required. Okay, great. Since we are very less in number, if one of you want to talk, you can unmute yourself and speak as well. That's completely fine.